Okay, let's do a numerical example. Let's say that we have a meter stick moving by you on a cart moving at 3 meters per second. How much shorter is the meter stick according to you compared to its proper length? I'm just trying to find a way to have a meter stick move relative to you. In its own frame of reference, of course, the proper length of the meter stick is 1 meter. And you know that you measure a distance equal to the proper length divided by gamma. We could fit this into the Lorentz transformation equations, but we know this about proper length and length measured in any other reference frame, so we can do it this way. We also know that gamma is equal to 1 over the square root of 1 minus v squared over c squared. So therefore, we can find that, L0 is, L prime is equal to L0 times 1 minus v squared over c squared to the 1/2, because it was L0 over gamma. So we can flip gamma upside down and get L0 times 1 minus v squared over c squared to the 1/2. Okay, well, we also know that our v is very small. It's actually very, very small compared to c. So therefore, it is an excellent approximation that 1 minus v squared over c squared to the 1/2 is equal to 1 minus 1/2 v squared over c squared. So, and therefore we can write L prime is equal to L0 times 1 minus 1/2 v squared over c squared. Okay, so what? Well, remember I asked how much shorter, not how long is it, but how much shorter is the meter stick. So how much shorter the meter stick is what is the difference between L prime and L0, right? So this is delta L. Delta L equals L final minus L initial, or L prime minus L0. So therefore, delta L can be written as L prime minus L0, which notice is, on the right-hand side, it just gives us minus 1/2 v squared over c squared times L0. So all I did was I subtracted L0 from both sides. If you subtract L0, you get delta L is what I've written down here. The negative sign, what does that mean? It means it gets smaller, right? Delta L, it's L final minus L initial, it gets smaller. And it gets smaller by that amount. What is that amount? Whoops, I don't know what that happened there. Go ahead and plug in those numbers, and you get minus 0.5 times 10 to the minus 8 meters. The meter stick actually gets shorter when it's moving by you by, what is that, 1/100th of a micron, or 5 nanometers. 5 nanometers, I think it is. It gets shorter, negative sign, by 5 nanometers. So here's just a mathematical aside, right? So in relativistic effects, you always get the Lorentz factor. The Lorentz factor comes into relativistic effects. The Lorentz factor is square root of 1 minus v squared over c squared inverted. And so therefore, if v is much, much less than c, which is going to be unless we say we've got an alien traveling close to the speed of light, something like that. If v is much, much less than c, therefore we can approximate the Lorentz factor as 1. Well, here, let me write it out. V squared. So this is not the approximation. So the minus 1/2. And so then we can approximate it with an excellent approximation of 1 plus 1/2 v squared over c squared. Or, right, that's the Lorentz factor. Do note that if we want 1 over the Lorentz factor, then 1 over the Lorentz factor is going to give us 1 minus 1/2 v squared over c squared. So those are the approximations that we will use continuously. And then if we're asking for the change in something, right, the change is usually the change from 1, right? How much does the Lorentz factor change it? How much does the relativistic factor change it? If there was no relativity, gamma would be 1. If there was no relativity, gamma would be 1. But this is the change. So this 1/2 v squared over c squared is how much is the factor by which something changes. So if I ask for a time dilation problem, in a time dilation problem, if I say I'm sitting on a couch watching TV and somebody walks by me at 5 meters per second, what's the time difference that we measure between the putting the popcorn in the microwave oven and when it's ready, right? The time difference is going to have a factor of 1/2 v squared over c squared. It's a mathematical fact that simply comes from the binomial approximation and the fact that we've got to multiply the time by a gamma or divide the time by a gamma. But the time difference is, and the length differences for these small, when we can approximate it as a small difference, that's going to be the factor. Okay.